Okay, so what does this 2512 in these parentheses tell me to do? What am I trying to find with that calculation? Yeah.
Is it the coefficient of like the 13th?
This would be the coefficient of the 13th term when a plus b, or when my binomial is raised to the 25th power, right? And do we remember what this calculation is called? What kind of a calculation this is? Go ahead.
Like what is that factorial? Or no?
Yeah, we do have factorials in the calculation, but it is a Caitlin, it is a combination calculation. Okay, which combinations are also used as to count how many different ways you can do something. Okay, and with a combination versus a permutation, it is how many ways can something happen if the order doesn't matter. That's a combination, versus a permutation is where the order does matter. So if we are wanting an example of a combination versus a permutation, let's imagine that we're having a race. Okay. And I ask for how many, there's 8 people in the race. How many different ways can runners finish in the top 3? If you finish first, second, or third, are you in the top 3? So does it matter which order you come in to be considered in the top 3? No. Then if I ask how many different ways can runners place first, second, and third, then does the order matter? Okay. So that combination calculation is also used in probability to calculate how many ways something can happen. Okay. So this is a combination calculation. If we did this by hand, did anyone try to do it by hand? It would be 25 factorial over 25 minus 12 factorial times 12 factorial. Or in other words, 25 factorial over, what is that, 13 factorial, 12 factorial? This becomes really fun, doesn't it? I could do the whole thing. 25 times 24 times 23 times 22 times 21 times 20 times 19 times 18 times 17 times 16 times 15 times 14 times 13 factorial. Whew! Over 13 factorial times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. How many of you are super excited about doing this calculation? Yes, please. May I have another? When the numbers are small, this calculation by hand isn't too bad. I did the first couple with small numbers in the lesson. Not a big deal. When we start getting big numbers like this is not fun. Okay, I'm reducing 13 factorial. 12 times 2 is 24. 4 times 5 is 20. There we go. Let's see. Can I divide anything else? 6 goes into 18 3 times. Oh, I can divide the 3. Like this becomes not fun. Would you also agree that this becomes not really pre-calculus level thinking? This isn't even middle school. This is when you first learned reducing fractions. It's at a little higher level than you did in elementary school, but it's still that it's not any more high level thinking. It's just more questions, right? So then the question comes, how do I do this on the calculator? Which I should have had open. If you don't have a graphing calculator in front of you, you might want to get a graphing calculator in front of you just so that we can practice this. So, from the video, we had the combination notations. this is the one we see in our binomial theorem, but we also had this notation says to do the same thing, and this notation says to do the same thing. Okay, so all of those are saying find the or calculate the combination. Kind of like if I ask you to take the square root or I ask you to raise something to the 1/2 power. Aren't those asking you to do the same thing? But the notations are different, right? Okay. So when I do this on the calculator, does anyone have your own calculator that is a TI-83? Does yours do, you have an 84? Yours probably, it does give you the, yeah, so you have to type the number first. Anybody else? Okay, everybody else, your calculator should let you just fill in the numbers. Mine let you fill in with the nice boxes. So I said that combinations are used in probability calculations, right? To count how many ways something can happen. So I'm going to hit the math button. And do you see this column here that says probability? So I'm going to move. I like to go to the left because it's fewer taps than to the right. Only one, but still. And in my probability menu, do you see any of the notations I just said that were equivalent? Factorial is, but even less than needing to type out what the factorial means, don't I see this notation, the NCR does not look like this, right? So on my calculator, I'm going to choose option 3. And we did what, 25? And then I go over to the other side. And what was that number? 12. Thank you. And when I hit enter, I am so glad I didn't have to multiply out all of the numbers that gave me that answer. So what I end up when I do it on the calculator, 2500, was it 3? Oh, I switched them. And then 300. Yeah, there's my dyslexia in play right there. Okay. So if I were doing the expansion, a plus b to the 25th, the 13th term would have a coefficient of that. Oops, 2 zeros, 300. There we go. And for anyone that watched the Pascal's triangle, we should see where this becomes inefficient to do that with Pascal's triangle. Okay. Any questions on the calculation for combination? All right. So to find the 9th term in this expansion, this is my suggestion. The binomial theorem finds the k plus 1 term. I am going to suggest that you always write k plus 1 equals 9. So k equals 8. Here is why I am suggesting this. You can be really good at understanding that k is not the term number, and then on a test, screw up. If you make part of the process calculating the k, solving an incredibly difficult equation for k, you're less likely to mess up and put 9 there instead of 8. I have seen it more times than I care to count. And if I had $1 every time it happened on a test, I would have a lot more nice pairs of shoes. Just saying. I could afford them. So, my suggestion is you always do this. Even as silly as it seems, obviously, if k plus 1 is 9, k is 8. But the physical act of taking that step, the kids that do this, they don't make that mistake on the test. Okay. So that means my k value is 8. And I'm going to remind you nk a to the n minus k b to the k. This is the only part of the binomial theorem that you have to have memorized because it will find every term, every single one. This is my a. This is my b. So now I'm going to go 19, take an 8 at a time. My a was x squared to the 19 minus 8. I'm going to actually substitute that in. Is there anyone in here that goes, I know 19 minus 8 is 11. Can I just write 11? Yeah. B to the 8. So then this is going to get me 19, take an 8 at a time, x squared to the 11th, b to the 8th. And I'm going to have you stop here for a moment before you do any more expanding and double check. These two exponents, 11 and 8, should add to make 19. If they don't, you've made a mistake. Okay. So now on my calculator, I want you guys to do it. Even if you didn't watch the video, go on the calculator and do 19, take an 8 at a time. Use the combination to do 19, take an 8 at a time. Now what we got? 75582. So my coefficient is 75582. X to the, oops, not B. I forgot to put the 2 in here. Oh my gosh. 2 to the 8th. You guys let me do that. 2 to the 8th, negative 2 to the 8th. I caught it. Somebody whispered it, but I'm deaf and I didn't hear it. Negative 2 to the 8th. We're good. Okay. I'm okay with from here to here. Can I lose the negative? What's going to happen when I raise a negative to the 8th power? It's going to be positive. Okay. I'm going to talk about something in just a minute. Remind me with this. If it were like 7. All right. And then I'm going to have x squared to the 11th. So I'm going to put my numbers because that's going to make up my coefficient and then my variables. So now I'm going to try to multiply that by 2 to the 8th. Good. If I get a number that is an exact number, I write that as my coefficient. If I had 75582 times 2 to the, let's just go 18th, and I got a number in scientific notation, don't multiply it out. Just leave it as the number we found and then times 2 to the 18th. Okay. I don't want the approximated number. I want the exact coefficient. And our calculator sometimes can't handle numbers that big. Okay. So we have 19. I wish I could cut and paste it. Somebody's going to have to remind me. This is going to be 1934 9, 9, 2, x to the 22nd, right? And again, I don't care if you get rid of the negative there because raising a negative number to an even power is always going to be positive. Okay, so let's pretend. Should that be an apostrophe? Is it short for let us? Let's
Yeah.
pretend. Okay. Let's pretend that my 75582 times negative 2 to the 7th times x squared to the 11th. I know it doesn't work. I'm just pretending that it had been an odd power instead of an even power. Can I leave my answer like this? I don't want you to, because I want you to understand what happens when I raise a negative to an odd power. This will be negative. Let's even just say that this was to the 17th. So it's too big for me to type into the calculator and have it give me the exact number. I want your answer to not include, I don't need the parentheses there. I don't want it written here. I want you recognizing. Do you see that this is what happened? What did I miss? Okay. All right. This shows that you know how to use the formula. This shows that you understand number sense. Do you agree? This shows a little more understanding. I want to see this. So that negative, if it's to an odd power, is going to come up front, and then I just have a positive number to the power. I'm taking care of the negative one to that power. Okay? Yes. You can just drop it, because I know raising a negative to an even power is going to get me a positive number. Raising a negative number to an odd power is going to get me a negative number. Great question. Any others? Did anybody have any questions on the Pascal's triangle, or do you want me to wait until Monday to look at that one? Pascal's triangle is fun. I love Pascal's triangle. I tolerate binomial theorem. Do you feel that way also? I know you watched it. Did it feel like it's way more fun? Like, it's not normal fun, math fun. Huh?
It felt tedious to do.
Right. But here's the thing. You, on the assignment, you're going to do however many rows of Pascal's triangle I told you to create. And then you're not going to do it every time. That's going to be your reference. And so then for all of the rest of the problems, you have enough rows. You just have to look back. You do it once and then you're done for that. Okay. So yes, you're right. It does start feeling tedious, especially if you had to do that every time. But any other questions from the instruction that you were not sure about? My dogs have gotten smart. I don't know that this needs to be on the recording, but